Okay, so let us wait for a couple of minutes to let the people join. So we'll start the session in 5 minutes. Okay, so welcome you all. This is our NPTEL live session of week 7 for the course of non-conventional energy resources. This course is taken by Professor Prathap Haridoss from IIT Madras, and we will be discussing problems based on week 7 course content in this live session. So, as my introduction, I am Lalit Bharti, and I am a Prime Minister Research Fellow in the Department of Physics at IIT Kharagpur. So this is our week 7. So in week 7, we will be basically covering the course content. So we will be basically taking the solar photo catalyst, solar photo catalysts. Then also in this week 7, some part of wind energy is also included. So we will taking wind energy. It will include questions on windmills and wind energy power generation. Then we will be taking previous week's problems, means week 6 quiz problems. So these three broad topics we will be discussing for today. So we start with our first question. This is question asked during photocatalysis to split water, hydrogen and oxygen form in the same chamber. So what is a photocatalyst? In a very simple manner, we use some material, let's say this is some photocatalysis which will react with H2O, and we will be getting H2 plus O2. So in our general setup, we have one cathode here, we have one cathode, we have one anode, and we will be getting H2 at one electrode and O2 at one electrode. So these are, let's say it is H2, let's say it is O2. So basically this setup, so this whole setup is in a single container. Or you can say in a single chamber. So by this statement is true that this photocatalysis happens in a single chamber, in a same chamber, and H2 oxygen and hydrogen evolution happens in the same chamber. So this picture is also the representation of hydrogen and oxygen evolution. we have co-catalyst nanoparticles. We get energy from photons. This is the energy from photons. This is represented by this. Then we get electron and hole pairs. By the electron goes to H plus, they react with H plus and give us this H2, whereas holes goes to another electrode and we get O2 here. So this is basically the first question. Then we'll move to the second question. Second question says harnessing wind energy is an indirect way of harnessing solar energy. So how can we comment on that? So how can we connect wind to solar? So if we have earth here and we have, let's say, sun here, and these are the rays. So if sun is directly hitting, if the sun rays are directly hitting earth, so this portion will be having higher temperatures, where these portions will be having lower temperatures. So due to the temperature difference, we will be having some wind currents. Their directions also depending affected by the coriolis forces due to the rotation of Earth. And same thing happens if we have this Earth surface due to the solar radiation. This air near the Earth will get warm and it goes up, and similarly the colder airs come down. So basically, this motion of or circulatory motion of winds, it creates a wind stream or current of wind, and by the current of winds we can harness the energy using our wind turbines. So somehow, or the by these examples we have linked the solar energy to wind energy. So we can say yes, so wind energy harnessing is an indirect way to harness solar energy. So this statement can be hold true. For the next question, horizontal axis wind turbines capture energy throughout the process of rotation of the turbine. So this is a horizontal type wind turbine, you can say, and by the rotation of these blades, we will be getting, we will be able to harness the energy. So yes, the statement is true that throughout the process of rotation of turbines, if the if the turbines are rotating, we will be getting energy. So the statement will be true. In our next question, it says the band gap of a single material photocatalyst being greater than the potential window corresponding to the electrolysis of water is sufficient condition for it to be used in photocatalysis of water. So we need to understand that band gap of the material plays a key role. So we'll see how. So if we have some material, it's its conduction band, this is its valence band, and this is the band gap. Let's say E. So for the photocatalysis, we need the solar insolation, or we will be having some photon incident with some energy h nu. So this photon to be absorbed by the material. So by that electron can go through valence to conduction band. This h nu should be comparable to the band gap E. So if this the condition is fulfilled, then we can say that yes, the energy will be absorbed. So either it should be higher than the band gap, or at least comparable or equal to the band gap. If it is lower than the band gap, the h nu or the photon energies are lower than the band gap, then have, we will not see any electrons going from valence band to conduction band, and we will not see any reaction to be happen, and photocatalysis will not occur in that condition. So this is the condition. So this statement is true. Okay. So we'll see the next fifth question. This is the photoelectrochemical reaction involves the flow of electron in external circuit. So this is shown as a photoelectrochemical. So by using sunlight, we are harnessing energy in presence of H2O or as the electrolyte. So we have two electrodes. So you can see this is the external circuit, and it is easy to understand that electrons are flowing in the external circuit and some potentials are created here. So the statement is true that yes, in the photoelectrochemical reaction, the inverse the flow of electrons in the external circuit. Again, a question on the photoelectrochemical reaction. These are the previous year quiz questions. So we'll be discussing all these questions. So in a photoelectrochemical reaction of water in the presence of TiO2 photocatalyst, which gas are generated at anode and cathode? So this is a typical photoelectrochemical cell. As here also we have seen that if this is your, let's say, anode material and this is your cathode material. So we have to see where we will be getting O2 and H2. So these are the typical reactions of anode reaction and cathode reactions. So the same reaction will be happening there, and here the electron will be absorbed and we will be getting O2, and oppositely we will be getting H2. So this is also the answer, and the question option 1 is correct. Then we have the second question. It says match the following steps to reach the final photoelectrochemical reaction of H2 gas generation. So we have 4 steps. We will see step by step which will come first. So we have migration of electron hole pair toward the surface, electron hole pair generation, incoming photoradiation, recombination of electron hole pairs, and reaction occurs. So we understand that first reaction will be the first action if we have some photoelectrochemical cell. So first we required is the solar radiation. So first will be incoming photo radiation. And second, a electron hole pair will be generated by the solar radiation. So second electron hole pair will be generated. Then these electrons and holes pair will go towards the surface, where H plus will be reacting with electrons, will be getting H2. In opposite electrode, will be getting O2. This is the third. Then the fourth option, recombination of whole pairs. So that is not the part of S2 generation. We have to minimize the recombination of electron holes pair to get higher efficiencies. And at the end, we will be getting, if we have S2 and O2, we can say that our reaction is complete. So reaction will occur. So our options are A to third, B to second, C to first, and D to fifth. So our option 2 is correct. So this was the question 2 based on the photo electrochemical cell again. This is again a simple mechanism of photo electrochemical cell. Then the question is, third question, use of a co-catalyst in the process of hydrogen and oxygen gas generation helps the increasing rate of electron hole recombination. So we have to understand they are asking for co-catalyst helps in electron hole recombination. So for our hydrogen and oxygen gas generation reactions, we want to capture more to more electrons and holes. So from our anode and cathode reactions, we are getting electrons at one side, holes in one side, and electrons will be helping us to complete this reaction. And but if our electrons and holes get self recombined, so we will be not getting electrons and holes to complete our reactions, and we will not getting this H2 and O2. So co-catalysts enhance the rate of reaction, but this statement is opposite of that. That in this statement they are asking that this catalyst helps in increasing electrons and hole recombination. That we don't want, because we don't want to recombine electrons and holes. So that statement is clearly false. Then we'll come to next question. The next question is sacrificial agents is added to increase the electron hole pair recombination. So basically sacrificial agents are, by the name we can understand, they sacrifice themselves. So whatever reactions occurs in the during the photoelectrochemical reaction, the side reaction will be taken care by sacrificial agents, and they will limit or reduce electron hole recombination, which is a much required for our photoelectrochemical reaction, photoelectrocatalyst reaction. So for this solar photocatalyst, we want electrons and holes, and we don't want them to recombine, and the sacrificial agents will help us for the reaction. So the statement is false, that they don't increase the electron hole recombination, they even decrease it. Then we come to the next question. So this question says particle size reduction decreases or increases the chances of electron-electron recombination, hole-hole pair recombination. So these both statements cannot be correct because there is no electron-electron recombinations, no hole-hole pair recombination. Only electron-hole recombination occurs because one electron plus one hole, they will recombine. Because they are opposite in charges, and holes are created due to movement of electrons, vacancy of electron. So they will recombine and they will vanish. Then the third and fourth statements are encountering a defect en route surface, and so if you have a particle size this and you have a particle size this, so by reducing the particle size, in this larger particle size you will be having more surface defects, where in the smaller particle you will be having less. It is like going to bulk to nanomaterials. So if you go from larger to smaller, your defects will be, you will encounter defect and root surface. Less encounter if we as we go lower in dimensions. So the statement 3 is correct. It will decrease the chances of encountering a defect and root surface. Okay, so this was the fifth question. The option third is correct. And fourth is also similarly incorrect. Then we'll go to the sixth question. This question says match the advantages and disadvantages of different type of movement. So we have one vertical and horizontal. So we have to see the advantages and disadvantages. So in the vertical axis, options are easy to access stronger winds. Wind energy is not captured throughout the rotation. So we have already done this second, wind energy is not captured throughout the rotation. So this is for horizontal. This is the advantage, like wind energy is captured throughout the rotation, but in the vertical type they are not captured throughout. So for vertical, this is the case. This is a disadvantage. Third, more turbulent flow of air near the ground. So because you see for a vertical axis, if let's say it is a vertical axis, so these are basically near to the surface, so they will produce more turbulence. They will produce more turbulence, hence more turbulent air near the ground. In compared to this vertical, the horizontal windmills are quite far than the surface. If you see, this is just representation, so I'm making it in a smaller scale, but the scale will be much higher. So this height is very high for horizontal type windmills. So there the air will not be turbulent near the ground as much as the in the vertical. So this is also for A. So for A we have second and we have third. So remaining for B, advantages, it is, this is also a disadvantage. Easy to access stronger winds. This is the advantage of horizontal type because they are at which is quite high height, so they will easily handle the, in this three blade design, they will easily handle the stronger winds. So the B, as well as the fourth, complexity with respect to setting up. So that is a disadvantage for horizontal axis because these are pretty much larger in size. They are quite complex compared to vertical type windmills. So we have first and fourth. So now we can compare A to second and third. So our fourth option is correct. It is also mentioned here. So here we discuss the difference between horizontal and vertical windmills. Okay. So now we have a next question. So if we see a large wind turbine of 2 to 3 megawatt with 35% capacity factor is installed in the region, then the number of wind turbines required for fulfilling the energy consumption of 500 exajoules will be how many millions? So this question is also done in the main classes or main tutorial, main lectures. So you can also refer to them. So basically we have, let's say 2 megawatt. So this is the power generation per hour, but still we have the capacity of 35%. So if we calculate, so 2 into 0.35. So this is for hour. So let's say for okay, this was for per second. So this is the power rate. Then we have to convert it in hours. Then 365 days. So we will getting some quantity here. And we want to be 500 exajoules, means 500 times 10 to the power 18 joules. So for that, we need to divide this quantity and you will be getting around 15 million. Or it here it will be 22 million. Similarly, if you calculate by 3 megawatt, it will be 15 million. So you can also refer to your PDF textbooks or your main lectures for this problem. So both 22 and 15 are correct. So this is a simple example of number of windmills required for fulfilling the energy consumption of world. So 500 exajoules is the roughly rough estimate of energy consumption by the humanity. So we will be needing around 22 million windmills, which is a very large number. So you can get an image or you can get an estimate of how many windmills are required. So this was the question. Then we have the ninth question where we have 4 points and we have to look in this figure and we need to understand what is A, B, C, and D in respect to a windmill. So from A, you can easily understand that there is no power production here. The power production is zero. So A is shutdown condition. A is your shutdown condition. Then power available to windmill, no power generated, reaches to the rated power. So C is your rated power. So you can understand that this was the, because here it gets saturated, so this is your rated power. Then B is the power available, but it is not sufficient to get rated power. So B is your option second. This is your option first. Oh, this is your option third, second, fourth, and these then it gets to again zero, no power, or in the shutdown condition. So we have this A2 3, B2 second, C2 fourth, and so we have this third option correct. Then we go to next question. So this is the required Bernoulli equation for wind energy calculation. So this is derived properly in the main tutorial, main lectures. So you can go through, refer to that because it have a large derivation. So basically the kinetic energy and potential energy with the air pressure, they are put together and the Bernoulli equation was calculated. So I am just writing the Bernoulli equation direct here. Since it is clearly mentioned in the main lectures, so this is your option fourth is correct. So now we have arrived to, we have done this week problem, and now we have week 6. These were the graded quiz. So week 6 quiz questions. So we will take this question. So we'll take a break of 5 to 10 minutes. Then we'll come back to the lecture. Okay, so we are back to our discussion. So we will discuss these previous week's questions. So the first question is, how does a PN semiconductor material differ from a PN junction? So this is just a P-type material, and here at the right side we have a PN junction. So we have the statements are electrons excitation occurs only in PN junction and not in P-type semiconductor. But that is incorrect because electron excitation can happen in this P-type also. You can see here. So it happens in both. So this statement is incorrect. Second is electrons excited in P-type semiconductor recombine in a very short time. So that is correct because main charge in P-type holes are the majority charge carriers. So although electrons get excited, but their lifetime is very less in p-type. So holes are the majority charge carriers there. So there the electrons can be created, free electrons, they can get excited, but they recombine in a very short time. So their lifetime is very less. So this statement is correct. Option 2 is correct. Yes. Third is charge carriers generated in PN junction move to the other side to attend low energy. So yes, if some or electrons are here and we know the bend bending of P type and N type PN junction. So electrons here. So electrons tends to come this side, and if holes are here, holes tends to go this side. So they tends to go to the opposite sides to attend lower energies. So the statement is correct. Yes, you can understand it by the bending of a PN junction. We have already discussed in previous lectures bend is bend, how bending happen, and what are the consequences of that. Then the fourth is P-type material has holes as majority carriers, correct? While PN junction primarily has electrons as the majority carriers. But this statement is not correct because PN junction have electrons and holes both, like shown here. They have electrons, they have holes. So PN junction have both. So this statement is also incorrect. So only second and third is correct. So second and third is correct. Then we'll go to next question. It says when a PN junction is at equilibrium, it's what is flat? The band structure is flat? No, because we know this bending, how bending happens, when happens. So when a PN junction is formed, and bending happens at the junction. So that is incorrect. Valence band at the junction. So no, because in bending, conduction and valence both bands got bending. Only the Fermi energy level gets flat because bending happens due to matching to match the Fermi energies. So the Fermi energies of both they will match, they will get flat, and both conduction band and valence band, they will go under bending as well as the whole structure. So this fourth is correct for Neeraj. We'll see the next question. A PN junction semiconductor material is kept in the sunlight for some time. What will be the bias conditions of the junction? So these kind of conditions we have seen in the solar cells. So if the solar cell is in sunlight, so if you go and understand solar cell, they will be in the forward bias. So you will be having electrons and holes created. That is correct. The fourth is recombination of charge carriers can be minimized by. So this is charge recombination is in the interest of solar cells. We have discussed in the photocatalyst cells, but here we are talking regarding the solar cells. So how can we minimize? So reducing defects, correct? Because at the defect sites, the electron holes combinations occur. So by reducing the defect sites, we can reduce the electron holes area, electron holes recombination. Using single crystalline material, that is also correct because if you use very high quality pure material, there will be very less defect. That is also same for that first option. Reducing the solar spectrum range, but solar spectrum range is nothing to do with this material. So recombination will not depend on the solar spectrum range, whatever the range is. So it is regardless of spectrum range. So this will not be correct. Fourth is using high ordered perfect crystalline metal. That is also similar to using a single crystalline of pure, very pure material. So both option first, second, and fourth is correct, and third is incorrect. So it is the discussion on electron hole recombination, how we can increase the solar cell efficiencies. So that is the reason why single crystal silicons are preferred for the solar cells for high efficiency. Then we have a question field. It says solar cell is which device and battery is which device, which is the voltage source and which is the current source. So in solar cell, we know that we have electron and hole pairs. So electrons go at one side and holes go at one side. So we get a flow of electron, which represent current. So this is basically a current source, where in the batteries, by a reaction of electrode and electrolyte, we get some potential. So we have some electrochemical reactions like lithium is going to lithium plus plus electron. So these all depends on the electrochemical series and the thermodynamics of the system. So basically we get a potential difference. Potential difference means a voltage. And due to this voltage, we get the flow of electron. So we can say that solar cells are the current source, but batteries are the voltage source. So this was the fifth question. So it is very easy to understand how and why solar cell is a current source and why a battery is a voltage source. The next question. This is the question 6. It is about the air mass coefficient or AM. So what is the AM? It depends on the direction direction of sun, like sunlight incident on Earth. So if it is at the space, because with different direction, the path traveled through the atmosphere will be different. So we will be getting different intensities of same sunlight with different angle. So in the out of the atmosphere, it is called AM0 because it has not affected by the atmosphere. If it is in the zenith, means the angle is 0 degree, then it is called AM1.0. And if angle is 48.2 degree, it is called 1.5. And if angle is 60 degree, it is called AM2. So AM1.5 is the standard is taken as AM1.5. So our options are air mass coefficient is density of air, not it doesn't represent the density of air. Equals to 1 when the sun is directly overhead. That's correct. This is the zenith case. Theta is equal to 0 degree. The zenith case is less than 1 in evenings or mornings. So that is not correct because it will not go less than 1. It is 0 only at the out of the atmosphere. Equated, or the fourth option is equated to 1.5 to evaluate panels. So yes, that is the standard AM 1.5. It is used to evaluate the panels, solar panels. So fourth is correct. So second and fourth, these are the correct options. Then we have the seventh question. It says two solar cells which are brand new but from different manufacturer. So as we have the different manufacturer, a lot of things can change. Their materials, their methods, and solar cell fabrication. Here the method is for the material synthesis. It is the materials is the quality of purity of material, type of material, it is single crystalline, polycrystalline, then overall fabrication and other electrical technicalities which is related to the fabrication. So we'll have the same fill factor, but for this fill factor we need this IMP, VMP, they all should be identical for both. So they may differ in the fill factor and they may differ in the short circuit. So they may differ in both short circuit voltage, short circuit current, and the fill factor both. We cannot say they will be exactly identical or will have same fill factor and will have same open circuit voltage. But their open circuit voltage will be same. VOCs are same for all because VOC depends on the type of material. So if they are all using silicon, most manufacturer using silicon, so the VOC will be same. So this statement is also incorrect. The first is also incorrect. Second and third is correct. Then we have the next question. So we have a load current, we have a photo current. So as we know from our previous discussion and from our lectures, load current going flowing through the load, it is a function of your photo current. So photo current what you are getting from your, so this is representation of photo current. So our option A is, or option B is simply directly the function of photo current. And load current is solar cell, it depends on the sunlight. So it is the load current is, sorry, it is not the correct. A is directly 1 and B photo current depends on the sunlight and it is linearly. The more the sunlight, you will be having more photo current and less sunlight you will get less photo current. So photo current is directly related to sunlight. And option 2 is also incorrect because it is not a function of internal diode current and reverse bias. So your our option 1 is correct here. All others are incorrect. Then we have the main question. So its statement is aging of a solar cell does not disturb open circuit voltage but impacts the fill factor drastically. So we have to see the statements. So VOC will not be affected. So option is shunt resistance which occurs due to the combination of charges and decreases with time. So that's correct. So we have to keep the shunt resistance high because they will help in recombination. So we don't want to get recombination. So the statement is correct. Second is internal material resistance, which is in the series of the solar cell circuit increases with time. It is also correct. So this is in the material. So by the time their resistance of materials will increase, so it will impact negatively for our solar cell overall efficiency. Third option is series resistance, which occurs due to the recombination of charges decrease with time. That is incorrect. And fourth, internal materials resistance will increase with time. With is in parallel to the solar cell. It is not in the parallel to the solar cell. So it is in the series. So your material resistance in series. So option first and second are correct. Then we'll see the next question. So increased solar efficiency of a tandem solar cell is due to what? So this is a tandem solar cell. So it is basically multiple solar cell stacked. So we have one solar cell here, one so different cells one by one for absorbing different type of light. So the options are so question is increased solar cell efficiency of a tandem cell is due to what? So reduced black body radiation loss. So but there's nothing related to the black body radiation here. Reduce recombination. Recombination will not be reduced because in each solar cell the recombinations are same. So whatever recombinations are in this first cell will be same, and second they will not be affected by the tandem structure. So third option is reduce spectrum loss. So that is the main key point of solar cell because tandem solar cells are designed to absorb so all wavelengths it can absorb. So these are designed to absorb maximum possible solar spectrum range. And fourth option is increased number of PN junction with different band gaps. So that is correct for tandem solar cell because they have more increased number of PN junction, multiple PN junction with different band gaps. So it has some band gap different, it has different band gap. So by that they will absorb almost all the solar spectrum. So option third and fourth is correct. So this was the last question of week 6 quiz. So for now we have done this discussion of week 7. So we have some time left, around 30 minutes, less than 30 minutes. So if I will be here if you have any kind of issues or any doubts in this lecture or the previously covered lectures. So you can let me know and we will resolve these issues. These videos are also available on the YouTube. Links are already provided to you. So if you find any issues, any queries, any questions during the YouTube video, you can also comment there. So I will get back to them through the comments. So we have around 20 minutes. So I will be waiting here for any kind of queries. Okay, so we will conclude today's session here and we'll continue with week 8 content of this course in next week at the same time. So, okay, thank you for today.